Hello everyone, this session is all about the M2 API walkthrough. Before we start with the APIs, let's quickly review the Sandbox website where we can find the relevant documentation for ABDM integration. First, click on the Documentation tab to access information about ABDM milestones, M1, M2 and M3. You can find the detailed M2 v3 documentation under the v3 Documentation tab, and you can download it from there. In the Postman Collection tab, you will find the updated Postman collection for the milestones, which is synced with the provided documentation. It is recommended to review the documentation before starting any development activity. You can take a look at various test cases, which are necessary to comply with ABDM integration, under the Test Cases tab. You need to implement APIs accordingly. In the FAQ tab, you will find common queries frequently asked by integrators regarding M1, M2 and M3 integration. Both technical and functional queries are listed here. Under the Upcoming Sessions tab, you will find links to various sessions and webinars hosted by ABDM. Finally, in the Resources tab, go to the Webinars section to access recorded videos by ABDM covering both technical and functional aspects of the ecosystem. M2 in ABDM primarily involves linking health records with an Aadhaar address, allowing users to discover their health records, saving user consents, and sharing health records after verifying consent. For more information, please refer to the detailed documentation uploaded on the website. Let's now begin by understanding the M2 APIs. Download the latest Postman collection as demonstrated earlier and import it into Postman. The first step is to authenticate the session. For this, we will invoke the Sessions API. In the headers, you need to pass three mandatory fields: request ID, timestamp, and XCM ID. The request ID should be a uniquely generated ID, and you can use GUID for this. The timestamp should be in ISO format, and the XCM ID would be SBX for the sandbox environment and ABDM for production. Often, integrators face an access denied issue when invoking this API because they haven't passed these three mandatory headers. If any of these headers are missing, you will get an error, so ensure that the headers are correct before consuming any API. In the request body, you need to pass the client ID and client secret provided by the NHA. Once you successfully invoke the API, you will receive an access token in the response. The validity of this access token is 1200 seconds. If you encounter an invalid credentials error, ensure that the access token hasn't expired. The next API is the Update Bridge URL API, which is used to set the callback URL where you will receive responses from asynchronous APIs for M2 and M3. The headers are the same as discussed for the Sessions API. In the request body, you need to provide the URL where you want to receive callbacks. You can either pass the URL of your own server or use online callback URL tools like Webhook or Pipedream. For demonstration purposes, I will set up a Webhook URL. Open Webhook site in browser and copy the unique URL and paste it in request body of this API. You will receive a 202 accepted response if the API is successfully invoked, and callbacks will be sent to the registered URL. The next API is the Registration of Bridge Services API. Before using this API, you must register a facility on the facility sbx.abdm.gov.in link. Go to the new portal and click on Registration. You can register your facility via your Aadhaar number by clicking on the Register Here button. Enter the relevant information and complete the process, after which you will receive a facility name and a facility ID starting with IN. This facility ID will be used in subsequent APIs. Now, let's return to the Registration of Bridge Services API. First, ensure that you pass the access token in the authorization header. In the request body, pass the facility ID and facility name that you received after registering on the HSPSBX website. The bridge ID will be the client ID. HIP name will be the facility name, type will be either HIP or HIU, and active should be set to true. You will receive 200 OK after success of this API. The next API is Get Bridge Service by Service ID. This API is used to retrieve the details of a facility using its facility ID. At the end of the API URL, you need to pass the service ID, which is essentially the same as the facility ID. Make sure to include the access token in the authorization tab. The headers are the same as those discussed in the previous API calls. This API does not require a request body since it is a GET request. The response will contain all the details corresponding to that facility ID. You can also refer to the saved responses for various positive and negative scenarios. The next API is Find Service by Bridge ID. This GET API is used to fetch all the facilities or services linked to the bridge ID, which is the client ID. The registered callback URL will also be included in the response. Ensure that you pass the access token and headers as discussed in previous API calls. Now let's understand the core aspect of Milestone 2, that is linking of health records. First we will understand the HSPSBX initiated linking. HSPSBX initiated linking refers to the process of linking care contexts by a health information provider. First let's understand the API sequence for HSPSBX initiated linking in the ABDM framework. HSPSBX sends a POST request to the ABDM gateway using the endpoint generate token. This is done to generate a link token. ABDM gateway processes the request and sends a response back to the HSPSBX on its registered callback URL via onGenerate token endpoint. This callback contains the generated link token. HSPSBX application initiates a request to link the care context by sending a POST request to the ABDM gateway using the link care context endpoint. The headers must include authorization, request ID, timestamp, XHIP ID, XCMID and XLink token which you have received in onGenerate callback response. ABDM gateway processes the request and sends a response back to the HSPSBX application. The ABDM gateway then sends a callback to the registered URL via link on care context endpoint marking the successful linking of care context. Once care context is linked, HSPSBX and HIU both will receive notify callback that will be demonstrated in data transfer use case. Moving to API implementation part. The first API is the Generate Link Token API, which is used to generate a linking token. As discussed earlier, M2 APIs are asynchronous, so you will receive the response via the registered callback URL. Ensure that the access token is passed in the authorization tab. In the headers, you need to include the mandatory fields, request ID, timestamp, XHIP ID, and XCMID. XHIP ID refers to the facility ID that will link the care contexts. In the request body, pass the Aadhaar address, Aadhaar number, name, gender, and year of birth. These demographic details of the patient must match the details in Aadhaar. Upon successfully invoking this API, you will receive a 202 accepted response, and the full response will be sent to the registered callback URL. The onGenerate response will be sent to the webhook, and you will receive the linking token in the response. This token is used for linking care contexts and is valid for 6 months. A common issue that integrators face with this API is that if the API is called 3 times for the same Aadhaar address, the system will block that address for 24 hours. I have one response where I am getting this error. Therefore, It is recommended to call this API only once and use the generated linking token. If you need another linking token, you must use a different ABHA address. For your reference, in saved responses you can view the success and failure scenarios. The next API is the Linking Care Context API. This API is called by the HIP to link the care context to the patient's ABHA address, once the HIP has a valid linking token. In the headers, pass the mandatory fields, request ID, timestamp, XHIP ID, XLink token and XCM ID. XLink token refers to the linking token received from the callback response of the Link Token Generation API. Other header fields have been explained previously. Also, please ensure access token has been passed in Authorization tab. In request body, enter the ABHA number and ABHA address of the patient. The patient's reference number should be a unique ID or number for each new request. The patient's display should contain the displayed information about the care contexts. Enter the care context details, which are the patient's individual health records. In the care context reference number, add a unique ID, and in display, enter the information about the health record. There are 8 HI types in the ABDM ecosystem. Here, you can pass the relevant HI type according to the created record. Count refers to the number of health records. If the API executes successfully, you will receive a 202 accepted response and also you will receive on-care context callback on webhook, confirming the successful linking of the care context to that ABHA address. In case if there are multiple care contexts to be linked on single ABHA address, then we need to add one more object in patient array if the HI type is different. For example here, in request body we have 2 HI types. Prescription and wellness record, that's why we add one more object. If the HI type is same then we will add one more object in care context array only. For the time being only one care context is being linked. You can see this linked record in the PHR app. Before logging into the PHR app, download the ABHA reference PHR app from the Sandbox website. Under Getting Started, click on Sandbox ABHA app and download the ABHA APK. Ensure you have the latest version of the ABHA app. Now, log into the PHR app using your mobile number to view the record. Once logged in, click on Linked Facilities, where you'll find all the facilities linked with your record. My facility is Singular I facility. When you click on View Details, you'll find all the care context details. Here, you can see that the visit ID is the same as the care context reference number passed in the Link Care Context API, and the visit details match those provided in the care context display. If you perform a pull record action, the HIP will receive a notify callback. After that, the HIP will need to send an on notify response, which we will cover in the data transfer section. Let's see the second way for linking care context, that is user-initiated linking. Overview. User-initiated linking is the process in which users patient search for their health records from ABDM-compliant health facilities. Once health records are found, users can link their health records with their ABHA address. The user must have a patient HIU PHR app in the current scenario, via which the user can start the discovery of health records and link the health records. For future reference, following are the steps involved in user-initiated linking. User searches for a health facility that they have visited in the past. The health facility must be a HIP, part of the facility registry, and linked with an HRP for discovery to be supported. User makes a discovery request via patient HIU PHR app, that is, requests the HIP to find any health records in their name. User shares his/her details through their PHR address. Details: shared name, date of birth, gender, verified mobile no with the HIP/HRP. The HRP/HIP is expected to search its database for any records that match this patient. If there is a match, the HRP/HIP returns with the care context details for the records available. If there is no match, the HRP/HIP returns an error. The user can now request to link the records, care contexts, with their PHR address. The HRP/HIP will perform the validation by sending an OTP to the registered mobile. If the authentication succeeds, the care contexts are linked to the PHR address. Now let's see all this process in PHR app for better understanding. After that we will see the sequence diagram and then the API's walkthrough in Postman collection. Now let's walk through the user-initiated linking or discovery flow sequence diagram involving three entities: the PHR application, the ABDM gateway, and the HIP. First, the patient clicks on Fetch Record in the PHR application, as mentioned earlier. Then, the Discover callback is sent to the HIECM to discover their health records via a Care Context Discover request. The HIP receives this callback, which contains the shared patient details. The HIP then triggers the onDiscover API, which is initiated by the HMIS LMIS application. This API shares the response to the Discover request along with the health records linked to that patient. It's crucial that the onDiscover API is called within 2 seconds of receiving the Discover callback. After this step, the patient can view their data in the PHR app and select the records they wish to link to their profile. The patient clicks on Link Record to link their health records. The ABDM gateway receives the Care Context Init request, which is sent to the HIECM to start the linking process with the HIP, and the HIP will receive a callback as Care Context Init. The HIP will then invoke the onInit API, sharing the response of the link initiation request. A reference number will be generated by the HIP, which will be used in the confirmation API. The HIP needs to send an OTP to the patient, as the ABDM does not handle OTPs. Once the patient enters the OTP, a Care Context Confirm message is sent to the gateway. The HIECM shares the response of the link initiation request with the HIP, including the Care Context Confirm callback. After receiving the confirmation, the HIP invokes the onConfirm API and shares the response for the link confirmation back to the HIECM. First, click on Linked Facilities, then click on New Facility. Search for the facility by typing its name in the search box and select it. You can directly click on Fetch Record, or if you know the patient ID, you can enter it. Here, I am entering the patient ID as Pat632, then click on Fetch Record. Once you click on Fetch Record, the HIP will receive a Discover call. Afterward, the HIP will send an onDiscover response with care context details, which will appear here. Here, you will find all records linked to your name. You can either select all the records found or choose just one. In this case, I am selecting one care context. When you click on Link Records, the HIP will receive an init callback. The HIP will need to send an onInit response, which will trigger an OTP for the patient. The HIP will then send the OTP. After the OTP is confirmed, the HIP will receive a confirm callback and will need to send an onConfirm. Once you click on Next, you will see a screen showing that the record has been successfully linked. When you click on View My Record, you will be able to see the facility listed under Linked Facility. By clicking on View Details, you can then view all the details of the linked records. Let's walk through the user-initiated APIs in Postman. First, when the patient clicks on Fetch Record in the PHR application, the HIP will receive a Discover callback at our webhook URL. In this callback, the HIP receives the transaction ID and patient details, along with the request ID in the headers. Copy the transaction ID and request ID from this callback for use in the next API call, which is CareContext on Discover. In the CareContext on Discover API call, include the authentication token in the authentication. Pass the request ID, timestamp, and XCMID as SBX in the headers. In the body, include the transaction ID received from the Discover callback. In the patient array, provide the patient details. In reference number, use the patient's reference number. In display, provide the patient's display name. For CareContext reference number and display, include the CareContext details. In HI type, include one of the 8 HI type, such as prescription, diagnostic report, OP consultation, discharge summary, immunization record, health document record, wellness record, invoice. If there is only one CareContext, set the count to 1 in the CareContext array. If there are 2 CareContexts, the count will be 2. If there are different CareContexts with different HI type, you need to add another object in the patient array. For example, you could add another object with HI type as OP consultation. In Matched By, ensure it matches the types specified, such as MR or mobile. In Request ID, pass the request ID received in the Discover callback. This API needs to be sent within 2 seconds of receiving the Discover callback to avoid errors. If not, you will see an error message like this: your facility name, for example, Rahul Hospital, is taking longer than expected. Please try again after some time. Upon successful execution, the user will see the records shared by the HIP. As shown in the image below, when the patient selects all or specific records and clicks on Link Record, the HIP will receive an init call to initiate the linking of the patient's health records. The callback will appear as CareContext init. Here, you will receive the transaction ID used in the onInit API, ABA address, and the patient's CareContext details that the patient has selected. After this, the HIP needs to hit the CareContext onInit API. Include the authentication token in the authentication. Pass the request ID, timestamp, and XCMID as SBX in the headers. In the body, include the transaction ID received in the init callback. In reference number, use AGUID or unique reference number. In communication mode, specify mobile. In communication hint, describe it as OTP. In communication expiry, specify the expiry time. This API contains all the metadata of the link. Note that the OTP part needs to be handled by the HIP itself, as ABDM does not send this OTP. Once the patient enters the OTP, the HIP will receive a confirm callback with the token or OTP. Lastly, the HIP should send the onConfirm API call. Include the authentication token in the authentication. Pass the request ID, timestamp, and XCMID as SBX in the headers. In the body, include all the patient details. Once CareContext is linked, HIP will receive notify call. After that, HIP need to send the data that we will see in data transfer part. We have a deep linking API that is used to send an SMS to the patient, allowing them to link their health record via the link sent to their mobile number. The API endpoint is SMS Notify too. Here's how to use it. Include the authentication token in the authentication. Pass the request ID, timestamp, and XCM ID as SBX in the headers. In the body, pass the unique ID in request ID. Pass the ISO timestamp in timestamp. Include the patient's phone number. Provide your facility's name and ID in the HIP name and HIP ID fields. Once you hit this API, the patient will receive an SMS with a link to connect their record with their Aadhaar address. This diagram explains the flow of data exchange in a Health Information Exchange Consent Manager (HIECM) system, where different entities such as HIU, Health Information User, HIP, Health Information Provider, and the Gateway Consent Manager work together for secure data transfer. Let's break it down. Step 1. HIU requests patient data. The process starts when the Health Information User, HIU, which could be a hospital or healthcare provider, requests access to a patient's health data. This request is sent to the Consent Manager, CM, to initiate the data exchange process. Step 2. CM notifies the patient and creates Consent Request ID. Once the HIU makes the request, the Consent Manager notifies the patient through the Patient PHR, Personal Health Record, app. The CM generates a Consent Request ID for tracking the request and asks the patient to grant or deny permission for accessing their health data. Step 3. Patient grants consent. The patient reviews the consent request in their PHR app and grants permission for the HIU to access their health data. Once granted, the process moves forward, and the Consent Manager can now handle the data transfer. Step 4. CM generates Consent Artifacts ID for HIPS. After the patient gives consent, the Consent Manager generates a unique Consent Artifact ID for each Health Information Provider, HIP, involved. If the data is being requested from multiple sources, each HIP will receive a separate artifact ID to validate the request. Step 5. HIU provides data push URL. The HIU shares its data push URL, which is essentially the endpoint where they want to receive the patient's data. This URL is sent to the Consent Manager, which will pass it on to the HIP. Step 6. HIP verifies consent and encryption parameters. Each HIP, which could be a clinic, diagnostic lab, or healthcare facility, checks the validity of the Consent Artifact ID, ensures the date-time range of the request matches the consent, and verifies that all encryption parameters are properly set. This is crucial to ensure the data is securely transferred. Step 7. Data transfer based on transaction ID. The HIP now sends the encrypted patient data to the HIU data push URL directly. This data transfer is tracked using a transaction ID assigned by the Consent Manager to keep the entire process accountable and traceable. Step 8. HIU notifies CM of success or failure. Once the HIU receives the data or HIP sends the data, it notifies the Consent Manager whether the data transfer was successful or if there was any failure. This final step ensures the Consent Manager has a record of the transaction's outcome. This diagram represents the secure and consent-based flow of patient health data, ensuring privacy while enabling data exchange between healthcare entities. First, let's see the data flow overview. The process of data flow starts once the HIECM has generated consent artifact. Consent artifact is generated only if the status of consent request is granted, and same is notified to HIP and HIU. HIU sends pushback URL to HIP via HIECM. HIP now bundles the care context or health data of the patient as per FHIR standards and share the data via pushback data URL. HIECM is notified the status of the data shared both by HIU and HIP. Now let's see the sequence diagram. In the data transfer process, there are three main entities. First, HIP, Health Information Provider. This can be a lab or HMIS, Hospital Management Information System, software that holds patient records. Second, ABDM Gateway, the central system managing data transfers based on patient consent within the ABDM ecosystem. Third, HIU, Health Information User. This can be a patient, doctor, or authorized healthcare provider who needs access to the patient's health information. Consent notification. After the patient grants consent or a pull record action is triggered, the ABDM gateway sends a notify callback to the HIP application with care context details. The HIP application responds with an acknowledgement, request HIP on notify, to confirm receipt of the consent notification. Data request. Next, the ABDM gateway sends a data request callback, health information request, to the HIP application that includes a data push URL, transaction ID, and key material, used for encryption. The HIP application responds with an acknowledgement, health information HIP on request, confirming that it has received the request and transaction ID. Data transfer. The HIP application sends the encrypted FHIR data directly to the HIU application using the provided data push URL. After this, the HIP will send the Health Information Notify API to the gateway, indicating that the data has been transferred to the HIU. Once you click on Pull Record or the patient grants the consent, the HIP receive a notify callback from the ABDM gateway. You can verify this in the webhook, where you'll see all the details of the care context in callback response. Here, you'll need to copy the consent ID from the body and the request ID from the headers. Make sure to send the onNotify API within 1 minute of receiving the notify callback to trigger the request callback. Now, let's send the onNotify API. First, pass the access token in the Authorization tab. In the headers, include all the mandatory values such as request ID, timestamp, XCMID, and XHIP ID. In the body, we are sending an acknowledgement by passing the status as OK along with the consent ID and request ID received from the notify callback. Once we hit this API, we'll receive a 202 response. Following that, the HIP will receive a Health Information HIP request callback from the ABDM gateway. This callback request will contain transaction ID to uniquely identify the consent transaction, consent details that are patient's approved consent, date range, the period for which the HIP should provide data, data push URL, the endpoint where the HIP should send the encrypted health data, key material for encryption, used to securely share the data. After receiving this request callback, the HIP needs to send an onRequest acknowledgement. To do this, pass the access token in the authorization header and include all mandatory headers like request ID, timestamp, and XCMID. In the body, acknowledge the transaction ID from the request callback and set the session status as acknowledged. The request ID in the body should be the same as the one received in the request callback headers. After hitting this API, you'll get a 200 response, indicating that no further callback will be received. Now, you need to send the data to the data push URL that was received in the request callback. Here's how you do it. Pass the access token in the authorization header. Include all required headers. In the URL, use the data push URL received in the request callback. This data push URL is from the ABHA app, as we have performed a pull record, and all the data will be sent directly to the HIU without any involvement of a gateway. In the transaction ID field, pass the transaction ID from the request callback. In the content field, pass the encrypted FHI bundle, which we'll cover in detail soon. For the other parameters, in the media field, use application FHI plus JSON. In the checksum field, pass the string or MD6 code. In care context reference, pass the value received from the notify callback. For the key material, crypto algo to ECDH, curve to curve 25519. And in DH public key, use the details provided in the request callback. Set the expiry and parameters based on the key material. For the key, you can either pass the key to share or the X509 public key, if using Fiedlius CLI. In the nonce field, pass your nonce. We'll dive into the FHI bundle and encryption part. Let's refer to the NRCE's website for the FHI bundle. The vision of the Ayushman Bharat Digital Mission, ABDM, is to create a national digital health ecosystem that supports universal health coverage in an efficient, accessible, inclusive, affordable, timely, and secure manner. This ecosystem aims to provide a wide range of data, information, and infrastructure services by leveraging open, interoperable, standards-based digital systems, ensuring the security, confidentiality, and privacy of health-related personal information. It also promotes the adoption of open standards by all actors within the national digital health ecosystem. In the ABDM profile, we have 8 health information, HI, types, diagnostic report record, discharge summary record, health document record, immunization record, OP consult record, prescription record, wellness record, and invoice. You can read the definitions of these HI types for more information. Let's see OP consult record. Here, you can find an example, along with a formal view of the profile content. In the differential table, you can see which elements are mandatory. For example, the composition status type is marked in red, indicating that it is mandatory. Additionally, observe the cardinality. If the cardinality is specified as 0 to *, it means that the element can have 0 or many instances. A cardinality of 1 to 1 indicates that there can be only one instance, and it is mandatory. If it states 0 to 1, the maximum is 1. If you see something like 0 to 1 or 0 to * with an S symbol in red marked, it means that it is mandatory. In the System Description and Constraints section, you can refer to the website link http://snumd.info for snumd codes. To find an example of this OP Consult FHI bundle, click on Bundle OP Consult Note Example 05 to access the sample example. Download the JSON file, and after downloading, you can validate the FHI bundle using the following steps. Validation steps. Before validation, these are the prerequisites. Ensure JDK 8 or higher. This is a Java-based command line application, so make sure that JDK 8 or higher is installed on your machine. Download the example JSON file. Here we have already downloaded the OP consultation example or created your own FHI bundle. Ensure the file is ready. Create a folder. At your preferred location, create a new folder to store the necessary files. Download the validator CLI. Download the validate_CLI.jar file of the required version from the provided link. Place the downloaded .jar file and the FHI bundle JSON file in the same folder. Running the validator command. Open the command prompt or any CLI application and navigate to the folder where the .jar file and the JSON file are stored. Use the following command to run the validator, as shown here. For example, if you have downloaded Bundle OP Consult Note Example 05 and the jar file name is validate_CLI.jar, the command will look like this. Once you run this command, the bundle will start validating. If there are any errors, they will be displayed, and if successful, you will see a success message. Once the FHI bundle is validated, convert the JSON into a string format. After conversion, copy the string for use at the time of encryption. So, to encrypt the string or FHI bundle, I will be using the Fiedlius CLI. You can find the code in this GitHub repository. In the repository, click the code button to download the zip file. Follow the steps in the README file for setup, which includes all the necessary APIs. I have already set up the code in IntelliJ and APIs locally. Let me walk you through the process using Postman. In the Postman collection, there are 3 APIs involved. First, generate key material. This API generates the key material required for encryption. Second, API encrypts the data, which will be used by the HIP. Third, API will be used by the HIU to decrypt data, covered in milestone 3. Generate key material. When you generate key material, you'll receive the private key, public key, and nonce. These are the sender keys. Copy these values and paste them into the encrypt data API. For the encrypt data API, provide the following. Receive a public key. Pass the public key received in the request callback as key value. Receive a nonce. Use the nonce received in the request callback. Send a private key, send a public key, send a nonce. Use the values obtained from the generate key material API. And in plain text data. Pass the FHI bundle after converting it into a string. Response. In the response, you will receive the encrypted data and a key to share. After obtaining the encrypted data, key to share, and other necessary details, let's move to the data push API. In the content field, pass the encrypted data that was received from the encryption process. In the key field, pass the key to share that you received in the response of the encryption API. In the nonce field, pass the HIP nonce, which was received in the key generate material response. Once all the fields are populated correctly, hit the data push API. After successfully executing the request, the patient will be able to view the data in the PHR app, as the data push URL being used is for the PHR app. Once the data is pushed, the HIP will not receive any callback. After that, the HIP needs to hit the Health Information Notify API to notify ABDM that the data has been successfully transferred to the HIU. Here's how to proceed. Pass the authentication token in the Authorization tab. In the Headers section, pass the following. Request ID. Timestamp. XCMID. In the Body section, pass the following details. Consent ID, the consent ID received in the Notify callback. Transaction ID, the transaction ID received in the request callback. Done at, pass the current date and time. Notifier ID, pass the HIP ID. Session status, set the value as transferred. HIP ID, pass your HIP ID or facility ID. Care context reference, the care context reference received in the Notify callback. Once you send this API request, you should receive a 202 response, indicating the request was successfully processed.